Welcome to Differential Equations. This is section 4.1. We're starting a new chapter on second order linear equations. And now we're doing activity 411. And so in this case, we'll do part A here. So x double prime minus 5x prime minus 14x equals 0. Now, also x of 0 equals 0, and x prime of 0 equals 2. Okay, so I'm going to do this one the long way and the short way, and then I'll do the other two only the short way. So the long way is to say, well, let y equals x prime. And so then you have this equation now would be like y prime minus 5y minus 14x equals 0. So I can rewrite these as x prime equals 0x plus 1y, and y prime equals 14x plus 5y, which means my matrix is 0, 1, 14, 5. And that means that my eigenvalues, so the trace is 5, the determinant is 0 minus 14. So lambda minus the trace, lambda squared minus the trace, plus the times lambda plus the determinant, which is negative 14, equals 0. So two factors of negative 14 that add up to negative 5 would be negative 7 and positive 2. So lambda minus 7 times lambda plus 2 equals 0. Okay, so then that means that, let me just pause real quick. So we have lambda is equal to 7 and lambda equals negative 2. And so then you get your eigenvectors with that. So to find the eigenvectors, we subtract, let's do lambda equals 7, lambda equals negative 2. So then with 7, you get 7, 14, 1, 5. That doesn't make any sense. Nope. 5 minus 7 is negative 7. 5 minus 7 is negative 2. Yep, doing arithmetic. Here we go. So then the Kyle numbers for this would be you could have 1 and 7. So you can't see that. So so there's subtracted 7 across the diagonal. The Kyle numbers would be 1 and 7. So then my eigenvector is 1 and 7. Okay. And then here, I've got negative 2, so subtracting negative 2 gives me positive 2, and 1, and 14. And then 5 minus negative 2 is 7. So some good Kyle numbers with 1 and negative 2. Okay, so then that means that my system is basically, if I had, forget about x and y now, and think of a new y. Now let me just use z, so I'm not double using y. Think about z of t, which is equal to t times x, right? So 1, 7, 1, negative 2 times x, okay? Then z of t, then multiplying, taking the derivative, means that z prime equals 1, 7, 1, negative 2. And then x prime, which is x prime is a times x. So I'll just, instead of putting x prime, I'll put a times x, 0, 1, 14, 5, x. And then, oh, I should have done z as inverse. It'll make more sense that way. And so then I can substitute, so I can move that over and substitute for x to be tz. So z prime equals 1, 1, 7, negative 2, 0, 1, 14, 5, and then tx, 1, 1, 7, inverse, 1, 1, 7, negative 2 times z. Okay? And so then that, because you've done this many times, you know that multiplying all this together will give you the diagonal 7, 0, 0, negative 2 z. Okay, which means that z equals e to the, so the first component of z is, it's 1, 0, e to the 7 t plus 0, 1 e to the negative 2t, and there's constants, c1, c2, so because of the, when you integrate. Okay, so then, like I said, I'm doing this the long way. I'll do it the short way at the end of this video. So then, if z is that, well, x equals t times z. So x is, t is 1, 1, 7, negative 2 times z, and z equals c1 e to the 7t times the vector 1, 0 plus c2 e to the negative 2t 0, 1. Okay? Then you see that so x is this matrix times that. So you just multiply this matrix times each of those vectors, and you get x equals, because if I have the matrix times the whole thing, then it distributes and constants factor out. So you just multiply it by each vector, and this times the first vector will give you the first row, and this times the first column, and this times the second vector gives you the second column. So x equals c1 e to the 7t times 1, 7 plus c2 e to the negative 2t times 1, negative 2. Okay? And now the fact that x of 0 equals 0. So when that means 0. So when I have so x of 0 equals 0. So that means really, when I plug in 0, I have 0, 2 equals c1 times 1, 7, because when I plug in 0 there, it just becomes 1, plus c2 times 1, negative 2. Okay? So then c1 and c2 have to kind of add up, have to be opposites of each other, and 7 times one of them minus 2 times the other will give you 2. And so then the top row gives me that c1 equals negative c2. And so then the bottom row then gives me that 2 equals 7c1 minus 2c2, which is really just plus 2c1. So c1 equals 2/9, and c2 equals negative 2/9. So then x equals, I've got Genevieve with me if you can hear her. She's starting to wake up a little bit from her nap. So then x equals 2/9 e to the 7t times 1/7 minus 2/9 e to the negative 2t times 1 negative 2. Okay, now that was a lot of linear algebra. And when you do the same thing over and over and over again, you might notice that when you do x double prime minus 5x prime minus 14x equals 0, starting over, doing it the shorter way. This is like a polynomial. R squared minus 5r minus 14 equals 0. What is r? Well, factor it. Factor is the same way as the characteristic polynomial. It factors as r minus 7 times r plus 2 equals 0. Okay, and so then that means we're going to have two different solutions, e to the 7t and e to the negative 2t. Okay, and then you can really just use those as guesses and just see how things work out. And so, in a way, let me pause for a second. Okay, there's one thing I forgot from the long way, is that this is really a vector where the second component is x prime. And you notice that e to the 7t, you take its derivative, you get a multiple of 7. So you take its derivative, you get times 7. Take this one's derivative, you get minus 2. So really, there's really no new information in the bottom row. And so all you really need was that x, the regular x, not x bar with x and x prime, equals c1 e to the 7t plus c2 e to the negative 2t. And then that's the original x from the original problem, where the original x I'm treating like that, and then x prime I'm treating like that. That's maybe bad notation, and I'm very sorry for that, but that's just the way things are working out today. Okay, and so then, but I've already solved for c1 and c2 now, so I know that x equals 2/9 e to 7t minus 2/9 e to negative 2t. And that's the final answer. Because the original question was not in terms of a linear question. The original question was in terms of a single number that had a second derivative in it. Okay? And so going back to our shortcut then, we have here that we have this is the characteristic polynomial of the system, the differential equation. We factor it, then the factors, 7 and negative 2 give us these. So then we say, well, x equals c1 e to the 7t plus c2 e to the negative 2t. And then you can just say, well, x prime equals 7 c1 e to the 7t minus 2 c2 e to the negative 2t. Then plug in x of 0 equals 0 and x prime of 0 equals 2, and then solve for c1 and c2, and then you're done. That's a shorter way. Okay, so in the next problems, I'll solve it the shorter way.